It means the things are growing forever. I'm not restricting it to a certain amount of days. Like if you do an experiment in a lab for science class and you try to grow bacteria in a petri dish, have y'all ever done that? It's pretty cool. If you try to do that, you eventually stop your experiment, throw it away, right? Uninhibited growth or decay means we let it go on forever. There's no restrictions, no time limits, okay? So think about if there's no time limits. Which formula did we use yesterday that had no time limits? Very good. Uninhibited growth and decay, you're going to use APERT. For all of it. If it says uninhibited, APERT. Compounded continuous, APERT, because there's no time restriction. Now, I am going to show you, do not write these, please, 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 do not write these, because then y'all will be like, wait a minute, those aren't the same. Y'all start freaking out, so just watch. Don't write it, just look. You could see either one of these as well. But what do both of those look like? APERT, it's literally the same thing. They just use different letters. Just rewrite it as APERT. Let me show you why. If it says N sub 0 or A sub 0, when X is 0, does everybody agree that that is the initial starting amount? That's the same thing that P means. Then they both have an E. The K for these is just called a growth constant. But if it's how much it's growing or decaying by, isn't that the same as the rate? Yes, and then time is the same. So I don't teach you these because once again, 2 more formulas that you have to memorize that could have been used with one you already know. Does that sound okay? So for all of these, we're just using APERT. Does everybody at home understand that?
Yeah.
Yes.
What'd you say? Yes, N sub 0 means when X is 0, so that's the initial amount. And in APERT, P is the initial amount. In the real world, X always starts with 0 because when you do any kind of experiment or anything, you have to write down what you first started with. Does that make sense? Like if I tell you to go run around the track and I time you, I'm going to start with 0. If we start measuring something's weight from the time it was born, when it's born, its ages, yeah. Like everything in the real world, experiment-wise, starts at 0. Yes, it'll tell you what it initially started with. Okay, we're about to do one just like that. Yes, ma'am. It could, but then it's not the initial amount. So then you would probably be solving for the initial amount. Does that make sense? So what they're asking in class, because I know y'all can't hear them. They said, what if they don't give you the initial amount? And I said, then you'd be solving for the initial amount. So you'd be solving for P. Or if they give you like A sub 2, then you're probably having to solve for P first so you can use the rest of the formula, okay? All right, so let's do an example off your worksheet. Let's do 11. So really, this formula should not be anything new because we used APERT yesterday, right? So I'm not going to do more than one example if that's okay with y'all. Are y'all good with just one example? All right, let's do it. So 11, the half-life of radioactive potassium is 1.3 billion years. We're about to get some big numbers. If 10 grams is present now, how much will be present in 100 years, in 1,000 years? So what do we know? What did they give us in this problem? Okay, they gave me the rate. Very good. Well, no, they didn't give us the rate, Kevin. They gave us the half-life. Does everybody see that? So in math 3, you learned a formula for half-life. I don't use that because it was a completely different formula. We are going to use APERT because if we're talking about the half-life of the potassium, it should be going up or down? Down. So we're talking about uninhibited decay. Okay? So I'm going to use APERT. Somebody give me an initial value because they don't tell us one, so somebody pick one for me. Okay, 10 sounds good to me. What is half of 10? So you should end up with 5 if I'm talking about the half-life. Does that make sense? You could do 1.5. You could do 2 and 1. Whatever. Yes, ma'am. So if 10 grams is present now, we actually can't use that yet. Does anybody want to tell me why? Veteran power. Huh? I don't know who that was. I'm guessing it's not. I thought it was Kelly. All right. So look, guys, if 10 grams is present now, then that means we know this is 10 and it's asking how much will be present. So we know this would be 10E. We don't know the rate. Does everybody see that? Now, we will know the time because it'll be 100, but we can't solve for either of these until we find the what? Rate. So that's why I'm saying it doesn't matter because we have to find the rate first. Okay? Jack, you okay? Okay. If you have a question, let me know. We don't know the rate, but we do know the half-life. How much was the half-life? 1.3 billion. I hate this problem because y'all don't know how to write out 1.3 billion. So let's review from, good, I hope you do. It's 1 and a 1, 3 and a bunch of zeros, LOL. It's 1. Yes, very good. So look, it's 1 billion. And then it says 0.3. So that would be 300 million. There's your thousands place. And there's your hundreds, tens, and ones. That is how you write out 1.3 billion. So I'm doing R times 1, 3, and 8 zeros is what they said in class. So all we have to do is solve this for R. Then once we find our rate, it should be easy because I can plug it in for 10 grams over 100 years and 10 grams over 1,000 years. Okay, but you have to find your R first. Yes, ma'am. How would you write 1.3 billion? In scientific notation, it would be 1.3 times 10 to the 9th, because you would move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Huh? Yeah, the scientific calculators, like the graphing calculators, use E instead of 10. But that's what the E means, the 10th place. Yep. Okay. So how would I solve for R? What would I do first? Divide by 10. And it's half-life, so we should end up with a half, right? So that means I did it right. So 1/2 E to the 1,300,000,000 R. You can put R times or you can put that R. I mean the same thing. I'm just trying to write it different ways that you might see it. Okay, somebody online talk to me. What do I do next? Because I got to get to the R, but it's in the exponent. So what would I do?
Log of both sides.
Okay, log of both sides. And what kind of log would it need to be, KJ, since there's an E?
A natural log.
Natural log, good. Or what? Loggy froggy. Which one do y'all want to see? Well, I would use natural log for either one. You not loggy froggy, you want to see it the other way? Okay, so if I take the natural log of both sides, that would be natural log of 1/2 equals natural log of E. Hang on. You smarty butt, smarty pants. We got to let them think of it, although I don't think they can hear y'all most of the time because the mic, I have it set on just the computer. All right, so Maddox is asking, can't we simplify the natural log of E? What's the base of the natural log? So isn't this one of your identity properties? It's just one, very good. So it really cancels, right? And then you would bring the exponent down. So this is natural log of a half equals 1,300,000,000, and then thousands and tens are, and then what's the last thing you would have to do? And then I'll answer your question. Divide by 1.3 billion. Very good. So I'm going to divide this to the other side. Daniel, you okay? Okay, you looked stressed. Am I going too fast? Let me know if I am. I'll slow down. I'm totally fine if you do that. Yes. All right, Kendall, what was your question? Yes. So remember, anytime you have a base of E, you're supposed to use the natural log, correct? So, and that's because if you do natural log of E, they will cancel every single time. If you take the log of E, it's not going to cancel. So make sure you do natural log when you see E's. Right. So we're not done. We're finding the rate. That's why these tend to be a little tricky because a lot of times you have to find the rate. So for the rate, I'm going to type this in with you guys. If you're using Desmos at home, that's fine too. Natural log of 0.5, and I'm old fashioned, so I like to go ahead and hit enter because I don't like to use a lot of parentheses. Divided by 1,300,000,000, thousands, hundreds, tens, ones. Oh boy. All right. I hate this problem every year, but it's okay. Okay. This is why I hate it, because a lot of you didn't learn this or weren't shown this in Math 3. This is my rate. Does everybody see this? Online people, yes or no? Y'all see this?
Yeah.
Yes.
Okay. I want to talk about this rate. If it takes 1 billion years for us to get half of something, that means it's going down very, very slowly. Very good. So this should be a tiny, tiny, tiny rate, which is what we got. Now, please, please, please listen carefully. Do you round this? No, because then it does what? It throws off your final answers. It throws off how much we would have after 100 years and 1,000 years. Good. Can you say that again so I can repeat it for them? Maddox said, so can't we store it as X? Did you guys learn that in Math 3? This is what I was afraid of. That's
Yeah.
Okay, good. So in Desmos, you should be able to copy and paste it into the new equation. But let me show you how you can store it as X in a calculator, okay? So I'm going to zoom this out just a little bit. If you hit this STO button, my math phone kids like to say, we're going to go to the stove. And I'm like, yeah, sure, whatever. Hit the store. That means I'm making my answer. I'm going to hit the X button up here where it says link. Hit that and hit enter. It does not matter if you press alpha X or that. Nope, shouldn't matter. So what I just did, guys, I made the X button equal this number. So now when I go solve for 100 years and solve for 1,000 years, all I have to put in for the rate is X, because I just stored this number as X. Pretty cool, right? Not bad. I showed you that in math too. You're like, I don't remember. That's okay. All right, so let's go back and look at our problem. We found our rate. Now it says if 10 grams is present, how much is present in 100 years? So guys, what am I putting in for the rate right here? X, because we just stored it in our calculator. Or if you're at home using Desmos, you can paste that number in. So watch what I'm going to do. I'm going to do 10e to the 100x in the calculator, and it'll tell me how much is left after 100 years. So 10e to the 100x we're going to talk about it. We're going to talk about it. Your calculator might have rounded differently than mine. Okay. They're confused. They're kind of freaking out. Not freaking out. They're asking lots of questions though, because we still ended up with 10. Somebody tell me why that makes sense. Yeah, somebody at home, talk to me. Why does this make sense? I'm making them think this morning and they don't like it. Somebody's going to click off. I'm just waiting. Where my smarty people's at? Hey, Chris Dinkles. Why does it make sense that we still got 10? Hello? If you don't know, say, I don't know.
I don't know.
Thank you. At least he's honest. None of y'all know why we still got 10?
What, because 10 times 10 is 100?
If we have 10 grams, everybody listen, if we have 10 grams, the half-life is 1 billion years. Then that means in 1 billion years, how much will I have? 5. So if it's only been 100 years, is it gonna go down any? Not really, because it's going down very, very, very slowly. Our rate was negative 0.00000000053319. That is a very small rate. Does that make sense? So I agree with the class, not y'all, because y'all acting like y'all don't know what we're talking about. Make sure you're paying attention and participating. This is not going to go down hardly any. So it makes sense that we got 9.9999999. 2 more, 4, 6, 7. That makes sense because it's barely decreasing. It takes 1 billion years for it to get down to 5. I like doing this problem because it makes y'all think. Are we okay with that part? The amount after 100 years is that. All right, now the problem also asked how much we would have in 1,000 years. So for the pink one, I'm going to do A equals 10 is my initial, E, my rate we stored as X, and I'm multiplying that by 1,000 now. So before you even type something in at home or before you even just sit there and ignore me, I'm roasting y'all today because I want y'all participating. If it's been 1,000 years and it takes 1 billion years just for us to get down to 5, do you think it's really going to go down much?
No.
No. So we probably are going to get 9.99 something again. Okay, so let's check. 10e to the 1,000, and then I stored my rate as X. And we've still got 9.999 something, but look, isn't this number smaller than this one? So it is gradually going down, okay? No, I'm just color coding mine. You could put A sub 1,000 because that's how you would write it. A sub 1,000 is 9.999994660. Is it an 8? Thank you. I'm old, so I can't see. There we go. Yeah, they are. Those calculators are very old. People at home, are y'all okay?
Yep.
All right, I'm a little worried, so I want everybody to try number 10 because y'all are very quiet. Try number 10. Everybody, y'all too. Try number 10. That says me. Those were the ones I was going to do, but then we did this one off the homework where it doubled, so I changed my mind. That's just for me to know. For me to know and you to find out. The ones circled are the ones I was going to have to try. Everybody try 10. I'm glad I did 11 with y'all. Y'all always be freaking out over 11. This is the notes. I'm about to show you a new formula in a second. But the good news is they put it, I believe, on y'all's formula sheet. So you don't have to have it memorized. You just have to know what the things mean and be able to use it. Everybody trying 10. KJ, Chris, Kelly, trying to think who else spoke to me. I think it was just y'all and Natalie. Y'all have an extra credit point or two. The rest of Chris is so excited. The rest of you, make sure you're saying something so you can get an extra credit point for being on. My Oswald, I'm used to you answering me. Do you have your siblings with you? Or he's just ignoring me. Zoom is so good. Oh, you play.
He's sleeping with me, that's why.
Oh, so you gotta be quiet. I understand. Got it. But now you got your point because you talked to me.
Is 10 like 1 and 2 on the front?
10 is not like 1 and 2. All of these are using APERT.
All right.
Because we're doing uninhibited growth or decay. It doesn't say compounding, so you're going to use APERT. We are almost done, y'all. We got 2 more examples, and then I'm going to turn y'all loose on your homework, okay? Which is in Delta Math, so I hope you have your computer. If not, it's okay. You'll just wait till you get home to start.
I have a question.
Okay, I got an answer.
All right, it says 18 months. Do I have to convert that to like, I don't know. It's confusing me a little bit.
No. What do you got to convert it to? You're right.
Years?
Yes, because it says blah, blah, blah. What will be the population 2 years from now? So it's asking you for time in years. So whatever time you put in also has to be in years. Very good. Look at you. Josh, you okay? You look like you're in deep thought. Okay, do you want my help? Kendall, I'll come check on you next.
Oh, I'm not raising
Oh, okay. It was like this. That's okay. So you put in 2. So it says it doubles in 18 months. So you should put 1.5, right? Okay. X over 18. That's okay. That might be why then. And it shouldn't be over, yes. Isn't it, what's it talking about? People? Yeah. Yes, please don't have a decimal. You can't have 0.6 of a person. My math one kids always say, well, what if they're missing an arm and a leg? And I'm like, that's still a whole person. Go try that. I think you have that in wrong. All right, what's all this? What's the times 2? No, you don't need that. You have to find the rate first, or did you already find the rate? Yeah, so you have to find, remember, this is just like, oh, you gotta find the rate first. Yes, and then I'll cover that. Exactly like we did down there. Yep.
So, what is the rate of God?
I would store it as X. Did you try to write it as a fraction?
No, but why is it not?
So this is just your rate. This isn't the 1 plus or the 1 minus. So it should be, yes, it should be a decimal. Yep. So if you're asking me for the answer, I have no idea what it is. I'm going to go make it. That should be okay. If it's not, then you'll have to convert your answer back to years by dividing by, well, 12 months in a year, because it did ask for the population in years, but let's see. I think it might be okay that matters. It does. I haven't done it yet, so I don't know 100%, but it does look pretty good. All right, so let's look at this because I'm getting some good questions. I'm going to do it above if that's okay with y'all. Let's use a different color. All right, the population of a city follows exponential law. So that means we're using what? Exponents. And usually if it says exponential law, that means growth or decay, which is APERT. Is everybody with me? So we're going to use APERT. People at home, ask a question if something doesn't make sense. If the population doubled in size over an 18-month period, so stop. If it doubles, are you guys fine if I use 2 and 1? Because 1 doubled would be 2. Okay?
Sure.
Do they say anything about a rate? So this is why a lot of you went ahead and just started trying to plug in the 2 years and the 10,000. Stop. You can't do that yet because you don't know the rate. But what I do know is that in those 18 months, it doubled. Now, the question is asking for years. I gave you months. You can't just go put months in. You got to keep the same time unit. So if I want it in years, what should I put in for the time? 18 months is how much of a year? 1.5. Very good. So the first thing you have to do on these uninhibited growth and decay usually is find the rate. So I got to find the rate first, then I can do what they're asking me to, okay? All right, so did y'all divide the 1? Yes? And you would still get 2. And then from here, do we want to see loggy froggy or natural log of both sides? Okay, I'll do loggy froggy this time because it ends up being the same. If it's okay with y'all, I'm going to move the equals 2 over here just so y'all can see it. So log base E, which means it's what kind of log? Natural log of 2 equals 1.5R. So how do I get the rate? What do I do now? Divide by 1.5. Excellent. And then the natural log of 2 divided by 1.5. Let's see what we get. Natural log of 2 divided by 1.5. 0.4620981204.
I got that.
This is correct. Yeah. Did you put parentheses after your natural log of 2? You closed it? Okay, I'll come look at yours in a second. I was about to say, you did the 18. So hang on, yours shouldn't matter because you converted the years to months. So just check your final answer with mine. Your rate will be different. Okay, so 0.462098, blah, blah, blah. What kind of number is this? Irrational. You can't write it as a fraction. It goes on forever. So what should you guys do with this rate? Store as X. Very good. So store, I'm going to hit the store button. Store my answer as X and hit enter and it'll spit it back out. That means it stored it, okay? All right, so now we know what our rate is. I stored it as X. So now, let me come up here. It says if the current population is 10,000, so that would be my P, what will it be 2 years from now? So I can put 2 in for time. So I'm trying to figure out the final amount. The initial, or what it is currently, is 10,000. E, my rate we stored as X, and then I'm multiplying that by 2 years. So if you go put that in your calculator, 10,000 E raised to the X times 2. Did you guys get 25,198 people? Okay. Perfect. You can't have 0.42 of a person, so this should be rounded as a whole number. So Maddox, your way did work. Cool. Usually it will. The 2 units from now, we're going to do some conversions and it won't. You have to convert at the beginning. Okay.
Doesn't matter if we tell you like equal or like house.
Wait, what?
And you're answering how you were.
Yes, I do care. Can we talk about this really quick? Rosh, y'all that were on office hours yesterday already know this. The pre-cal exam 2 years ago. So this was when I taught Emma Frensko, Sarah Ithapathachai, Ryan Hodges, Philip Williamson, that whole class. Okay. On the final exam, there was a exponential equation. All right. And 2 of the answer choices had the same number and different units. And do you know that half that class chose the wrong daggone answer? I wanted to beat them. So yes, know what units you're talking about, because I think the answer was like 3.86 days, but a bunch of them chose 3.86 years. And I was like, really? So yes, I do want you to put the units. Pay attention to your units. Okay? All right, so before I show you your last formula, I do want to make sure we know how to do these in the calculator. Kevin, I'm going to pick on you. It's not in a bad way. Kevin has been using the TI-84. It's so much easier to see these in Desmos. So are you guys okay if I put one in Desmos just so we can look at how to do it in Desmos really quick? Okay. There's no notes on it. We'll just answer the questions about it in Desmos. So I'm going to do this top one. So keep number 8 out so you know what I'm doing, but I have to stop sharing my worksheet. And I'm going to pull up Desmos. Well, son of a gun. There we go. I'm going to get these children. They might be having internet issues. I'm going to give them the benefit of the doubt. All right, graphing calculator. So in Desmos, does everybody see on number 8, it says the size obeys the function, and then it gives you an exponential function? Do y'all see that? Okay, so I want you to watch. You can do it in the calculator, but Desmos is a lot easier to see. So I just want you to watch what I'm doing in Desmos. So I'm just going to do y equals 500e raised to the 0.02, and I'm going to put x because Desmos likes stuff in y and x. Okay? All right. And where is the little booger? There it is. So y'all see how I zoomed out and then I could just easily see the graph? That's the first thing that's better about Desmos, because in the TI-84s, you can try zoom fit, but a lot of times for exponentials, it still won't fit the whole thing on the screen. So Desmos, if I do this, I can see the whole thing, okay? All right, it says determine the number of insects at t equals 0 days. So I'm quizzing you. Did you need the graph to find that? No, if the time is 0 days, where can I look to see the initial amount of insects? You don't need to look at the y-intercept. Yeah, look at your equation, the P. A equals PE to the RT. Isn't the P the initial amount? So what's the initial amount of insects? 500. You don't need to look at your graph for that, right? 500. Yes. Good. So Grace is saying the reason it's 500, make sure you're listening to this because this is also the reason why. If you put 0 in for X, that'll be 0. E to the 0 is 1. 500 times 1 is 500. So the initial amount of insects is 500. Please do not act like you don't know how to find that. That make me very sad when they do that, Daniel. Next thing, what is the growth rate? Do you need the graph to find the growth rate? No, look in the equation where? The exponent beside the x. What's the growth rate of these insects? 0.02 or 2%. Very good. So we've got 500 insects initially. And our growth rate, I'm going to put a percentage because typically if it's multiple choice on your exam, it's in percentages. Okay? So 2%. Are y'all okay with A and B? I'm thinking you guys did a lot of this in math 3. Am I right or wrong? Did we do this in math 3? That's okay. I'm thinking you did. They had y'all use the calculator a lot. All right. What is the population after 10 days? There's 2 days you can do this problem. Somebody tell me one. What's one way I can figure this out? Good. Grace said plug 10 in for the X. So if you plug 10 in for the X, you'll get an answer. Another way to do it, this is what Kevin has been doing. Go find, and I'm just going to do it this way. I hope you are watching my screen. Go find when the days equal 10. Go find where X equals 10. Do you guys see how it drew a blue line? Do you guys see how up here they touch? Click where they touch. In 10 days, how many insects do I have? Okay, good. 611. You can't have 0.7 of an insect. Not if it's 0.7. Round up. The pre-cal exam, if it's bigger than 0.5, will round up. Okay? So after 10 days, there's 611 insects. If you plugged in 10 into the equation, you still should have gotten the same thing. We're okay with that? Yes. All right. When will the insect population reach 800? Again, there are 2 ways to do this part. What is one way? Plug it in for what? Good. Put 800 in for the Y, and you can solve for X by hand. Well, what's the other way we can do it? That was algebraically.
Oh, I'm
Good. Yes. So graphically, you're okay. So Y equals 800. Again, it'll graph that for you. Go find where they cross and click it. And how many days does it take for my insects to reach 800? 23.5 days. Perfect. People at home, are we okay?
Yep.
Okay. So then the last question, part F, says, when will the population double? What was our initial amount of insects? So you could either put in, yep, 500, good. You could either put in 1,000 for Y and find it by hand, solving, taking the natural log of both sides, bring the 0.02 back down, or you can just type in Y equals 1,000. Well, let's go look. So when does it double? After how many days? 34 point, do 2 decimal places for me. 34.66 days. People at home, easy or hard? Do we remember doing this?
I don't remember this, but this is really easy.
Okay, good. That's fine. That's a good answer. Is anybody not okay? All right. Y'all are good. What about, it just said graph it using a graphing utility. Desmos or a calculator. Yeah. So listen to me carefully. On your test, there are 2 of these, and it says use a graphing utility. So for those 2, do I need to see any work? No, I'm telling you, you can use Desmos or you can use your calculator. If you want to do it by hand to check yourself, go for it. But unless you typed it in wrong, the calculator's not going to lie to you. Okay? But then there's some on the test that say solve algebraically, which means I'm going to check your work paper and I should see stuff by hand. Are we okay with that? All right, last formula I have to show you, and it's an easy one because it's one that you don't have to remember. It will be on the formula sheet. Yep, see worksheet for examples. Last one, y'all hang with me. I will not go to the bell today, I promise. Because you don't have to memorize this formula, you just have to know how to use it, okay? So, and instead of doing the one on the worksheet, no, I'll probably do the one on the worksheet. All right, last formula. This is my fave. So I bet y'all did not know this was a thing. Jack, what you drinking? Is that a smoothie? It was okay, can I use it as the example? Sure, okay. Jack has an icy in class today. So what happens to an icy after you've had it for a long amount of time? It starts to melt because it's getting warmer, right? Okay. Same thing as if I have hot coffee. The longer I have the coffee, the colder it gets. Did you guys know there's a formula that will help you figure out like at what specific time it'll be what specific degrees? For real. Newton's law of cooling. You ready? Here it is. It looks crazy. This is why I'm thankful y'all don't have to memorize it because my kids last year had to. Just write it first and then you know I'll go through and tell you what everything means. I'll go through and tell you what it means. Because it does look long. Huh? Newton made life harder. His formulas are ridiculously long. This? No, it's not.
When are you ever going to have to figure out?
Scientists
exactly when your pizza is?
Scientists use this all the time. So cooks and stuff don't have to because they want their food to be hot, like when they get food out to you. So yeah, they don't use it. But scientists use stuff like this in experiments all the time when they're trying to figure out when an element will be cool enough for them to touch, stuff like that. It's not just for food. I just used food examples because I like food, okay? All right, T stands for the temperature of the environment. So for example, this room is hot as HE double hacky stick. So Jack's icy probably started melting really fast when he got in here. Whatever temperature this room is at, that's what number would go there, okay? That is the same T down there, yep. So this T is the same. Thank you, Maddox. What do you guys think U sub 0 is? It says sub 0, so what do you think? The initial temperature of Jack's icy or the initial temperature of my coffee. So this is your initial temp. What is R? The rate. What is T? The time. So let's talk about it. If I have hot coffee that is getting colder, what kind of rate do you think I would have? A decay, a negative rate, because my coffee is getting colder. The temperature is going down. Jack's icy that was already cold is getting warmer. So what kind of rate would his icy have? Positive. Does that make sense? This is the formula we're going to use. So let's look at the example on your worksheet. I'm just going to help you set it up. I shouldn't have to do all of it with you. Hopefully. I think we'll be okay. It's the last one. Try to get it where y'all can see both. Do we have to put the, no, you'll just plug none of the numbers in, okay? So for A, I'm gonna bring this down here. People at home, are y'all okay?
Yes.
Sure.
Thank you. Okay, so if the pizza is baked at 450 degrees and it's removed, 450 degrees is the initial temperature of the pizza. Does everybody agree? Okay. Blah, 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 blah. It's removed at 5 p.m., put in a room that is 70 degrees. So that is the temperature of my environment. Good. After 5 minutes, it'll be 300. Before you can start doing A, B, C, D, what did I not give you? The rate, which means we have to find what first? You have to find the rate, okay? So we know our pizza ends up at 300 degrees. So 300 equals 70 was the environment temperature plus what was the pizza's initial temperature? 450 minus 70 because it's minus the environment temperature. E, and then we don't know the rate, but we do know the time has been how long? 5 minutes. Just remember your time is in minutes, okay? R will be negative because the pizza is cooling. Very good. So it will be negative. I am going to solve this quickly because I don't want the bell to ring on y'all. Don't pack up. I have 3 minutes. I just want you to know I'm going to go kind of fast, okay? The first thing you would move is the 70. You can't go touch the parentheses yet because they're attached to the E, which is attached to the exponent. So I'm subtracting 70 first. Are we okay with that? Because y'all always solve this wrong on the test, and it kills me because this is technically math 1. You should know to move the 70 first. So this is going to be 230 equals, and then are y'all fine if I do 450 minus 70? That should be 380, right? Y'all check my mental math because sometimes it is not great. And then I'm going to write 5R. Then I'll divide the 380, and that'll be 23 over 38 on this side. I'm going to leave it as a fraction so I don't have to round, equals e to the 5R. From here, I need to get to the R. It's in the exponent. What do I do? Loggy froggy or natural log of both sides, or you could use Desmos. If it says algebraic, take the log of both sides. You writing this? Or are you going to watch it later? Okay, that's fine. I'm going to do log of both sides. Natural log of 23 over 38 equals natural log of E. 5 to the R. What happens with natural log of E? It cancels. Good. So this is going to be natural log of 23 over 38 equals 5R. Divide by 5. And this will give me my rate, right? Log of 23 divided by 38. And then divide that by 5. I had to remember where we were at. I'm getting negative 0.1 as the rate. Now don't round it because it does keep going. What are we going to store this as?
X.
Good. So I'm going to hit store as X. Store as X. Hit enter. If you're using Desmos, you can just copy and paste it. So I stored that as X. And I think I'm running out of room. So if it's okay with y'all, I'm going to use a whiteboard for the rest. Thank you.
Okay.
All right. So from here, we're going to do part A. At what time can you begin eating if you want the temperature to be 135? So we don't know the time, but I do know I want it to be 135. Are you okay, Taryn? If I keep going? Okay. I know the room was 70. I know the pizza was initially 450. E, and then my rate is now X, and can I now solve for T?
Yeah. Mm.
Yes. Now, you could totally do this by hand. I am also okay with you using Desmos for this one. So do you guys care if I go use Desmos for it?
Sure.
Because it says using a graphing utility. So if it's good with y'all, I want to use Desmos. So did y'all get the equation written down?
Mm-hmm.
Okay.
Miss Poole, where did 135 come from?
It says in part A, at what time can you begin eating if you want the temperature to be 135? So 135 is
Okay.
the temperature we want. Okay?
Okay.
All right. So let's pull up Desmos. Taryn, you good if I use Desmos? Yeah. Cool. All right. And we're going to type in, we're not going to type in the 135. We're going to go look where y is 135, okay? So the first equation is just 70 plus 450 minus 70 e raised to the, oh crud. Okay, if you're using a calculator, this is where you did the x. I'm going to type the number 004183888. And then we're trying to find the time.
Wow.
Okay, so let's talk about why it looks like this. And I am recording this for them that'll watch it later. So eventually your pizza is going to get to what temperature? Eventually, if you just leave it and let it sit out for forever. What will it get to? Oh, I just told y'all with Jack's example. How warm was the room?
Hot.
No, the room was 70 degrees.
Oh, my bad.
So you're good. If you leave the pizza sitting out for forever, it's eventually going to get to 70 degrees, right? That's
Yeah,
why the graph flattens like this, because it's not going to get colder than 70. It'll reach 70. Okay? But we want to look where it'll be 135. So at what time will it reach 135 degrees? 17.58 what?
Minutes.
Good. Sydney, don't sound like you guessing, girl. Minutes.
Sorry.
You're okay. 17.85 minutes is when it'll hit that, or 17.58, excuse me, that 135 degrees. Are y'all okay with that part? Yeah?
Sure.
Okay, so then part C says determine the time before the pizza is 160 degrees. So instead of 135, now I'm just going to type in 160. And the time it needs to be for 160 degrees is how much? Good. Taryn's the only one answering me. What y'all doing? Y'all okay?
Oh, I was writing it down.
Okay, but what's the time, Kelly? Tell me the time, girl.
14.34 minutes.
Thank you. Good. Y'all feel okay with this one?
Yeah.
All right, there's two of them on Desmos, and then the other Desmos ones, there's some compound interest, there's some growth decay like we did today. I put a little bit of everything on the homework so you can practice for your test. Okay?
Yep.
All right, I have office hours 3 to 4. If you need my help with the Delta Math homework, join office hours. Sound good?